All right, my friends, let's play with some macro data. I want to focus on this idea of converting from nominal to real. You probably at this stage of your trading understand that real adjusts for inflation, but I want to make sure you know what that actually means. Nominal is the price that we see, the price that we pay per unit of whatever it is. You pay $4 for a carton of eggs or whatever it is. Real is what you adjust for inflation, but think about what that actually means. There's a formula that you might have seen before, like you see on the screen here. Real is nominal divided by some junk in a denominator. That junk is based upon the CPI. Now, you could use a PCE, a PPI, some measure of prices. The T's represent time. Specifically, since it's the CPI, we're talking about months. So it's real, means the inflation adjusted. You take the price that you observe, nominal, all in a given month, and you divide it by the CPI in that month. That's almost adjusting for inflation. What you want to do is actually adjust by a fraction, the CPI in a given month divided by the CPI in the base year. And if you remember, the base year is going to be the anchor. And if you take the CPI divided by a base year, that kind of sounds a lot like a percent change, right? New divided by old. This is like a percent change. So what you're doing is saying, take whatever price you pay for whatever the object is, and then divide it by the cumulative amount of inflation we've seen since the base year. That bottom, that denominator, is kind of like deflating things. There's a name called the deflator. Real is nominal divided by deflator. So we're going to take the price I see and bring it down by the amount of cumulative inflation over that period. The way I want you to think about it is the price change that I observe in any given object that I buy has two components. That price change is built from relative and absolute. I'm buying, glasses cases or whatever it is. And maybe more people are wearing glasses, demanding these cases. Maybe Scott Harris is just really hot right now relative to other products. That would be a relative price change. But then it could be that the price of this and this and everything else is going up because the value of the dollar that's used to buy all this stuff is going down. The purchasing power is going down, absolute terms. So what's real doing? Real is saying, forget about all of that absolute stuff. Adjust for the data from the CPI, adjust for the absolute, and just focus on the relative. That's what real is doing. Focus on the relative. So what you could do is you could actually take what's called a Fisher equation. Um, percent triangle, percent delta, real. So 1 plus whatever is the change in the real at a given point in time is equal to 1 plus nominal change, 1 plus inflation change. So it's kind of like the formula you see on the left, but it's a transformation. It turns it into growth rates. Now, you could be much more rigorous, you could use logs, etc., but this is going to give you a really good estimate. There's actually a quicker proxy, Fisher approximation. You take your change in nominal, subtract off your change in the CPI, which is inflation, and you get approximately the change in real. So if you see that prices of, whatever is the object again, glasses cases is going up by 5% and inflation is going up by 2%, 5 minus 2. So the real change is 3. It's a pretty good proxy. Now, I want to put that into practice as always, right? We have to take the theory to the data. So let me scooch on over to Excel. Here we go. So I got a bunch of tasks for you. First thing we're going to do is call in the CPI and eggs prices. Now, this one happens to be non-seasonally adjusted, but whatever. Average eggs prices, grade A, large cost per dozen. I looked at 2024 because if you were buying this stuff in 2024, it was ludicrous. And actually, even in 2020, 21, we saw massive changes. I want to examine those nominal, examine the inflation, turn them into real in several different ways. So you go ahead, you got one date, you got month, 2024, January, 2024, December. I entered those. Once you got these tickers, I don't want you to do any transform, LIN. You go to Fred, you go to get data, boom, and you get all that. Now, What I want you to do is compute the total growth over that period. Now, technically, if I wanted everything in 2024, what I should have done is gone back to December, but that's enough for our purposes. Total growth over that period of CPI 2.3. So there was a total over that year of 2.3% inflation. Do the same formula, just drag it on over for eggs prices over that period. Eggs prices went up 64%. All right. Again, that's not quite 2024. I should have gone back to December but of 2023, but that's good enough for our purposes now. Think about it, right? So eggs prices went up 64%. That's a change. How much of that is relative? How much of that is absolute? Well, inflation is the absolute. So it's probably somewhere around like 60, 62% is relative price changes. Let's break that down to get to the real. So first thing I want to do, I'll check on one of these formulas here, is actually construct the rate of inflation. And there's a couple ways that you could do that. So one way is actually to use the real, but I think it's going to be easier just to do it like this. So what we're going to do is we're going to take the rate of CPI divided by the rate of CPI in the base period minus 1. And what I want to do is lock in the base period, put in the F4 so that it's always referencing that CPI value. And then what I want you to do is drag that down. Oh, all right, this will be a little bit more intuitive. So on any given month, period T, remember the T subscripts, I'm going to take whatever is the CPI divided by my base period. And here I'm going to call it January 2024. So I read any of these numbers as being from January to August 2024, inflation, overall absolute inflation, according to the CPI, was up about 2%. Okay, so I could do that across all that period. Let me highlight that. Now, let me take a look at eggs prices. Suppose I take the regular rate of eggs prices, and you could actually just put this over here like so. And what I do is I'm going to grow that. And we know eggs prices grew, but I'm going to grow that by the rate of aggregate cumulative total inflation since that base period. Notice I have the double dollar sign on E7. So everything, next one down, is referencing E7. Go on down, referencing E7. So what I'm doing is saying you paid $2.52 in January of 2024. If eggs prices didn't have any relative price changes, if it was only absolute, only about the change in the purchasing power of the dollar, they would have been $2.56 by April and $2.58 by December. Clearly, they didn't do that, right? They were up to $4. So there was a massive relative price change as well. That's because of egg price dynamics with supply demand. There was avian flus, etc. Not just the absolute. Let's see if we can measure the change in the purchasing power of the dollar. The absolute is about the change in the purchasing power. Inflation is a result of dollar weakness, a decline in that purchasing power. So it's very closely related. Inflation is the new divided by old minus 1. Purchasing power is old divided by new minus 1 because it's the opposite. It's the reverse. It's the inverse. Purchasing power, inflation. That's a weakness. So all you got to do is reverse it. So what it's saying here, when you take that formula, and again, it's always locking into B7, is that the purchasing power of the dollar relative to January 2024 was down 2.28%. Yeah, basically the rate of inflation. The dollars by the end of the year were weaker, smaller. Imagine like the physical dollar bill kind of like shrinking or cutting in pieces than they were at the beginning. Monetary policy movements, etc., caused that. So if you take a look at the total change in the growth of that eggs prices have grown by the CPI, lo and behold, you get 2.3, which is exactly the rate of inflation. That's manufacturing. Let's see if we can actually convert that to real. So when you go over here, take a peek. I didn't write that. That comes directly from the BLS. Index 1982 to 1984 equals 100. That's the base year. So let's adjust for inflation the way that you would typically see. Nominal divided by real. Pardon me. Nominal divided by CPI-T, CPI base year. Remember. Real is nominal divided by the fraction CPI-T, CPI base year. Nominal divided by CPI-T, 310.326 divided by CPI in the base year is 100. That's the 1982-84 equals 100. So you do that for all of the periods. So what is 1.314 saying? Eggs that cost you $4.14 in December 2024 would have cost you $1.31 if I used 1982, 1984 dollars. You see, the dollars back in 82 were stronger. Our dollars have gone weaker because of that absolute decline in the purchasing power of the dollar. So I could have taken those strong 1982 dollars and bought that same carton of eggs for only 1.3 of those stronger dollars. So I can decompose that. Take a look. Remember we had over here, go back to the slides, Fisher equation, 1 plus percent change in the real is the growth rate gross of nominal, growth rate gross of inflation. And you can, you could actually take that, G18 divided by G17, that's the growth in real, but you can use the proxy to exactly derive that. Look at that. That's 1 plus C21, which is nominal, divided by 1 plus B21. That's inflation, minus 1. Matches exactly what's on the formula up at the top, which, my friends, is 60.65. This is directly from the change in real, and that's our proxy. So you don't need to actually do the conversion. So break that down. That means that eggs prices went up by 64%. Inflation was up 2%. So the real growth was 60.65. And in fact, you could use our simple proxy, which is just a subtraction of those two, and it's pretty darn close. Inflation went up 2.3, nominal went up 64, real about 62. Now, these numbers here about using a base year real formulas work, it's perfect. I wonder though if that's really telling a good story because that's referencing all the way back to 1982, 1984. Another way to do it is actually change the base year. So let me zoom out a little bit and let's use January 2024 as the base year. And let's do this. So C10, what's C10? C10 is going to be eggs prices in time period T, that's April. And then let me divide it by the CPI B10 in April 2024, divided by B7, right? B7. I didn't do B7 before. Look at this. Before I did divided by 100. Well, 1982 base year was 100, but now I want to re-index it to a new base year or base period, which was January 308.417. That's why I'm dividing it that way. And again, go back. That's exactly the formula. Nominal divided by denominator, CPI-T, CPI base year. So I set a new base year. And I do that, remember, lock in the B7 with the double dollar sign. And I get 4.052. What does that mean? Let me scooch over so you could read as I speak. Eggs cost you $4.14, 15 cents in December 2024. If you use January 2024 dollars, which are a little bit stronger, it would have cost you $4.05. Not $4.14, $4.05. And why is that? Because the dollar weakened through time. If you go back in time, the dollars that you had, you can imagine, again, that piece of paper was actually bigger, stronger. So I needed less of them to buy the same thing. 4052 versus 4146. There's another way you could index as well. Let me index to December 2024. Okay, I'm going to scooch so you can see. Take the CPI period T, C10, pardon me, eggs prices, nominal, in period T, C10, divided by CPI, CPI base. Again, that's the formula. Go back to PowerPoint, nominal divided by CPI, CPI base, nominal divided by CPI, CPI base. Now I'm locking in B18. B18 is that December 2024. Do that for all the periods. Make sure you double lock down on the dollar signs. And now you get, let me scooch over. Boom. Eggs that cost you 252 in January 2024 would have cost you 258 using December 2024 dollars. That's different than all the others, right? So now it's costing me more. Why is it costing me more? Because I'm indexing to a period in the future. I'm indexing to a period where the dollars were weaker. So it's going to take more of those dollars to buy the same product. And then check this out. Look at this. When I use December 2024 as the base year, in December 2024, it cost me $4.14. But that's exactly what I saw for nominal in the base year. Real equals nominal. If you like formulas, real equals nominal. And then think about that denominator. If the time period T is the base year, then you do CPI base divided by CPI base, it's just one. And that's what's happening here. So every time you're in that base year, every time you're in the base year, you get real equals nominal. No matter what you do, what you use as benchmark, you get the same level of real increase. All right, my friends, hope that helps.